Hello everyone. In this video, we are going to discuss operations on a linked list. So let's start. All the data structure operations can be performed on a linked list like insert, delete, traverse, search, sort and merge. Insert operation. In linked list, a new node can be inserted or added in different position. In the beginning of the linked list, in the end of the linked list, between two nodes, means after a given node. Each node in linked list are known by their element. So what we'll insert, we will insert a new node after a given element or after a node containing the given element. We can also insert a node before the given node, means the node which containing the given element, we will add a new element before that particular node. And then you can also insert a node on the particular position k. This is known as positional insert. So in this positional insert, we have to count the nodes in the linked list, and when we reach the kth node, we can insert a new node on that particular position. There are certain conditions which we have to take care. So let's start with the description of the insert operation. To insert a new node in the linked list, you have to change the next reference of the new node to refer to the next reference of existing node. Means if your linked list is something like this, head, node, then again a node, then node, and last is null, then you have one tail. So if I want to insert this particular node at any position, consider the first, what I have to do, I have to refer the next node. I want this node's next node to refer to the existing list, and then what I will do, I will refer the head to this particular node. So the new node will refer to the existing list, and the existing list, that node after which or before which we are doing inserting this element, have to refer to this particular node. In the case of add first is the insert at beginning. Add first as the insert at beginning. The head will refer, as we shown in the example. The head will refer. Okay. So head will refer to the new node, and new node next reference will refer to the existing list. If the linked list is empty, there is a case when you want to add the first but the linked list is empty, then head and tail both will refer to this particular new node. So consider this, head is referring to null, there is no element, tail is also referring to null. This case comes in the when the linked list is just created and there is no node in the linked list. Now if you want to add a new node, then what will happen? If I want to add this particular node next will refer to null, and head will refer to this, and tail will also refer to this particular node. Why? Because when there's only a first node, that particular node is the start as well as the end. Okay. Now consider the case if you want to add last, that is on the tail node. Means the tail node next reference will refer to the new node, and tail you have to update the tail also refers to the new node. So what we are doing in this particular, consider this scenario, if you have had and there's some node in the linked list, you do not know the exact number, and this is your last node, last node which is referred by tail, and it is referring to null. Now what happens? Now what will happen? Now if you want to insert this particular node in this linked list at the last position, this tail's next reference has to refer this node, and you have to update the tail by removing this reference and adding this reference. Means tail will refers to the newly inserted node. But what happens if the linked list is empty? Linked list is empty means there's no node. So now head is null, referring to null, and tail is also referring to null. And if I want to add a new node, in this particular linked list, what I have to do? I have to let the head refers to this new node and the tail refers to the new node. So whenever you are adding the last and the linked list is empty, it's better to call the add first method or insert the node at the beginning, because in both the add first and add last, when the linked list is empty, we are following the same steps. Okay. Now let us consider the scenario of insert at head. Insert at head means, as we discussed earlier, this is your existing linked list, and you want this node to be part of this linked list. So what you have to do? The node next reference will refer to the existing list referred by head. Means you have to set this reference. You have to set this particular reference. Then what you have to do? You have to update the head. Now head is referring to the new node. The node is the new head of the linked list. See, the new node is inserted in the linked list, and the inserted node become the head of the linked list. Now look at the scenario for insert at last or add last, which is also known as insert at tail. See, if I want to insert this particular node at tail, what I have to do? Node next reference will refer to null. So first I have to set the next reference of the node to null. Then the tail next reference will refer to node. Now I have to set this link. Okay. And then what I have to do? I have to update the tail. Tail is also referring to this new node. Now this node will become the tail of the linked list. So see, the tail is updated, the old last node is pointing to this particular node, and tail is also updated. So in this particular way, what we'll do? We will add the last. Now if I want to add a node in between an existing list, by the means of after a given node, will identify the node by the element it contain. So in this particular thing, we are considering that each element in the linked list is unique. In case of duplicacy in the element, this node is inserted after the first occurrence of a given element. So see, in this particular linked list, what I want to insert a node which containing 3 as an element, where I have to insert after the element 6, after the node which containing the element 6. Okay, means after this particular node. So what I have to do? For this particular thing, we have to traverse from head. We have to start traversing from the head and find the node containing the given element. If not present, node will be not inserted. If 6 is not present in this list, I cannot insert this particular node into the linked list. If the node is present, then what I have to do? The new node next will refer to the existing list. Means the new node next reference will refer to the next reference of the node containing that particular element. In our case, 6 is this is the node and 6 is the element. The next reference is referring to the node which containing 7. So what we have to link these two, we have to link these two, and then what we have to do, node containing the element on that particular node next reference, we have to that next reference will refer to the node, means now this link will be removed and 6 will refer to the new node which containing 3. In this way what we'll do, we will insert after a given node. So see, this new node is inserted after the given node. The new node is inserted after the given node. And why it's in between two nodes? Because we have inserted in between 6 and 7. We inserted in between 6 and 7. Now we'll see the scenario before the given node. Before the given node. See, in linked list, whenever you want to insert a node, you must know the previous node of that particular position. So you can change the next reference of that particular previous node. So see, if I want to insert 3 after the node which containing 6, before the node which containing 6, means between 8 and 6 I want to insert. So what I have to do, I want reference of this particular node, I want reference of this particular node. Why? Because this node now will refer to the new node, this node now will refer to the new node. Let's see the process. What we have to do, for this we have to traverse from head again and find the node containing the given element, find the node containing the given element. If not present, the new node will not be inserted, the new node will not be inserted. So in this before procedure, what we have to do, for inserting we need reference of the previous node. So what we'll do, we'll keep a track of this previous node, we'll keep a track of this previous node. Now what happens when we find the containing node as well as the previous node, then the node next will refer to the next reference of the previous node. Previous node का next what we have to do, we have to let the node next will refer to the next reference of the previous node. The previous node is this particular node. Now what we want, the next of this node will also the next of the new node, means the now this node will refer to this particular node. And the second thing what we have to do, we have to update the previous node next reference, we have to update the previous node next reference, so it will refer to the node. Now what we'll do, we will convert this arrow like this, we will change the reference, okay. In this way we are going to insert before the given node. So see, 3 is inserted before 6 and it is inserted between 8 and 6. So in this scenario, in this way what we can do, we can add before a given node. Now we'll see the particular position k. If I want to insert a node on the position, insert at kth position, now k is 3, means I want to insert this node on the third position means what I have to do, I have to keep track of this and I have to do insert in between 2 and 3, okay. In this manner we have to do, but this k must be greater than 0 and less than equal to the size of linked list, If k is a negative position, k is 0, we cannot insert because we have first position, second position, third position and fourth position. We cannot insert at 0th position. It is possible, you can understand it is possible because you can either add, you can either what we have to do. If k is valid position, if k is valid position, that is k is greater than 0 and less than equal to the size, we will identify which node, k minus 1 node. We will identify which node, k minus 1 node. Why we need k minus 1? Because we want to change the next reference of that particular k minus 1 node. In our case, k minus 1 node is 2. K minus 1 node is 2. Node next reference will refers to k minus 1 node next reference, means now node will refer to this particular node and k minus 1 node next will refer to the node, means this will now refer to this particular node. In this manner what we'll do, in this manner what we'll do, we will insert the new node at the kth position. So how we identify? How we identify? We have to start from head and traverse by counting. Traverse by counting and keep a reference to this. But on the positional insert, what we can do? We can count till a k minus 1 position. We can count till a k minus 1 position and we will be able to insert. So this kth position scenario, this insert operation will take O of n time. Likewise, the insert after a given node and before a given node also containing traversing, that's why they will also give O of n time. But add first and add last will give you O of 1 time, O of 1 time. So those methods are efficient method. In these methods, we'll have to traverse the list. Now moving forward, see, we have to insert the new node on the kth position where k is equals to 3. See, our new node is inserted on the third position, So that is all about the insert operation. Now we'll look at the delete operation. Likewise, we can add a node into the linked list and delete a node from the linked list. So a node can be deleted or removed from the linked list from the beginning of the list, from the end of the list, in between two nodes, means we can delete a given node. We can delete a given node. Each node is known by the given element. That means containing the given element, we have to delete the node. Now to delete a node, a linked list must contain a node, otherwise we will not be able to delete, neither from beginning nor from the end, not from in between. Okay, so to delete a node, that node must be present, and the last scenario is from a particular position k, if that k is valid position. The process of deleting is, to delete a node from linked list, we have to change the next reference of the node which is just before the deleting node. Means again we have to keep the track of previous, so we will call it previous node, we will change the previous node next reference to the deleting node next reference. What we'll do, we will update the next reference of previous node with the deleting node next reference, and that particular node will be now removed from the linked list, So see, the first scenario, if we are deleting node, if the deleting node is the first node, okay, if the deleting node is the first node, what will happen? Then head will refer to the deleting node next reference, okay. If the deleting node is the last node, then tail will refer to previous node. Means if the deleting node is the first node, head will be updated. If the deleting node is the last node, tail will be updated. Okay, the previous node then become the last node, which is the tail. So tail has to be updated. So now delete from head or remove first. We want to remove this particular node. This particular node. What will be the process? Head will refer to the next reference of the first node. Head will refer to the next reference of the first node. Means now head will refer to this. Head will refers to this particular node. Okay. If there's if there is one node, then head and tail both need to be updated. Then head and tail both need to be updated. Consider this scenario. If this is the node and this is the only node, then what happens? We'll have to update the head to the next, which is null, and also the tail to the next, and also the tail to the next. Okay, so there is a special case of a single node. In case of multiple node, head only will be updated. So what happens? Now 12 is removed from the linked list. Head is referring to the next node of 12, which is 3. Next node of the 12, which is 3. Okay. And what happens in the single node scenario? Head and tail both refers to null. Okay. Moving forward. Delete from tail or remove last. Now if I want to remove this particular method, what I have to do? To delete from last, we have to traverse. Now as opposite to add last, we have to traverse from head and reach the node before the last node. Means now we have to reach to this particular node. Why? We want to update this particular next reference to null. Okay, and then we want to update tail to refer to this particular node. So what we'll do? Previous node next reference will refer to null, and tail will now refers to previous node. See, we have updated both the references, tail as well as the next reference of the second last node, and this particular node is now deleted from the linked list. Moving forward, deleting a given node containing the given element. If I want to delete a node which containing element 6, what I have to delete this particular node. How we are going to delete? By getting the reference of the previous node. To delete a given element, we have to traverse from head to a given element node, and also save a reference to the node before it. Okay, so we have to save the reference because we have to update the next of this particular. We call it previous. Now if this given node containing this value is not present, then deletion will not be performed. Okay, previous node next reference will refer to the deleting node. Next reference means this will refer to 8. This will refer to the next node of the deleting node. Okay, see, node which containing 6 is removed from the linked list. So tell me, what will happen if the deleting node is the first node? Means if the containing element is 12, what will happen? Now head will refer to the next node. Okay, head will refer to this particular node. Again, one more scenario. If you have only a single node, I'll say 12. What happens in single node scenario? Head and tail both need to be updated. Okay, So some people will say this is the overhead of the tail, this is the overhead of the tail. If we do not have the tail, we simply, what we'll do, we will simply update the head by the next reference of the head, update the head by the next reference of the head, and in both the scenario, in single node and multiple node, that particular thing will work. But with tail, we have to especially consider the especially consider the single node scenario. Okay, now deleting from the position k, a positional delete. So here also we need k must be a valid position. How k will be valid? K will be greater than 0 and less than equal to size, greater than 0 and less than equal to size. Then delete is performed, otherwise delete operation will not performed. Okay, see, if I want to delete a node at kth position where k equals to 3, then what? I have to delete this particular node. Again the same thing. I have to track the reference of the previous node and update the next pointer of previous node. In kth position, what we'll do, we'll start counting and we'll stop at k minus 1, so in this we do not have to keep track of the previous, we just traverse from head to the previous node, because we know the position, we know the position of the previous node. We'll start from head and find the k minus 1 node. Then k minus 1 node next reference will refer to the kth node next reference. Means this is the kth node, its next reference is this, we have updated this. Okay, and then this particular node will be deleted, this particular node will be removed from the linked list, this particular node is removed from the linked list. So guys, this is all about delete operation. Now we'll look into the operation of traversing. Okay, what is traversing? Traversing means visiting each node of linked list starting from head to last node. What we have to do? We have to start from head and we have to reach each node from head to last node. Traverse operation is needed for processing of each node. Now if you want to print the value of each node, you have to reach each node, that is by traversing. If you want to search an element in the linked list, again you have to compare the search key with the each element of the linked list. If you want to perform some operation like sum of all element of sequence, then you have to again traverse the linked list. So traversing, you have also have notified that in insert, after a given node and before a given node we are traversing. For positional insert we are also traversing. For deleting a given node, we are also traversing the linked list. For deleting a kth node, we are traversing the linked list. So traversing operation is connected to various operation in the linked list. So how to traverse? As we all know, linked list known by its head reference. Okay, so head reference is most important reference in the linked list. We are only aware about the head reference. Okay, so what we'll do, we will assign head reference to a temp reference for a traversing. Why? Because we do not want to corrupt the head. If the head is corrupted, then we will not be able to locate all the nodes of the linked list which are not deleted from the list. So we have to keep track of the head and we do not let traversing from by head. We will always keep a temporary reference and we'll assign that temp reference the value of head. So starting from head node, we will visit each node by getting the next reference. Okay, next reference of that particular node. So we will reach each element of the sequence. Till what time we have to get the next reference? Until we reach the end of linked list. Until till we reach the end of linked list. The end of linked list is denoted by a node whose next reference is null, whose next reference is null. Okay, so till what time we have to update the next or the head, till we need reach the last node. So what we are doing here for traversing, we are assigning the head to the temp. See, head and temp now both refer to the this particular first node, this particular first node. On each iteration, updating the temp by temp node next reference. This is the temp. Now updating the temps means temp is referring to the next node. Temp is referring to the next node. Okay. Till what time we'll do? Unless we'll find null. Unless we'll find null. Okay. Then again, the next is not null, so we'll update the temp. Next is not null, we'll update the temp. Next is not null, we'll update the temp. Now next is null. Next is null, that means we have visited all the element. We have visited all the element. Okay. So either what we'll do, we will check if the next reference of the temp node is not null, then we'll update the temp. If it's null, we'll do not update. The other process is that start from the head, assigning the head reference to the temp, and iterate till the temp will become null. Iterate till the temp will become null. Okay. These two approaches you can use for traversing. These two approaches you can use for traversing. So see, repeat until temp is null. Temp refers to null when no more elements left to be traversed. Okay, left to be traversed. So this is the traversing. Now we'll look into the another operation, which is search operation. Searching for a given value, which is search key in the linked list. Again we are saying that linked list contains unique element. If though that linked list is not containing the unique element, this search operation will return the first occurrence. This search operation will returns the first occurrence of that element. Okay, that search key can be present, cannot be present, can be present more than one time. Okay, so what we can do, we will only give the first occurrence of that particular search key. Consider this, considering the search key equals to 6, considering the search key equals to 6. So what we have to do? To search, you have to traverse from head by using a temp reference and comparing search key in each node data. Comparing search key in each node data. If the search key is present, you will find the node containing search key. Otherwise, temp will reach to the end of linked list, means at some point temp will become null. Okay. So either you will stop when you find the search key, or you can stop when the temp is null. So see, until the temp is not reached the end of linked list, compare temp data with search key. If match, stop. Otherwise, update the temp by the temp node next reference. The process of traversing. We'll start, we'll compare the data we do not found, we'll update. We'll compare the data we do not found, we'll update. We'll compare the data not found, the search key found. Okay, we will now return true that this particular search key is present in the linked list. So in this process, what we'll do, we will search. This search is known as linear search. Okay, we are visiting each element and comparing. This search is known as linear search. One more interesting operation is the sort operation. Sort operation means arranging the elements of a linked list in some order, ascending or descending. Okay, either in the increasing or the decreasing order. How you can sort? There are two techniques. You can sort by rearranging nodes, by changing the next reference, or by switching the data value of the node. So Changing the next reference, we required complex operations for maintaining the references. So easier approach is to change the data value. This is possible when the data value is not declared as a constant. If the data value is declared as a constant, then we have to change the references. So consider this particular linked list, okay, which is not sorted. What we are doing, we are comparing the first node with the second node, the element of the first node with the element of the second node, and we are trying to perform ascending order, okay, or increasing order sorting. So what we'll do, we change the reference, we'll change the data value, now the first two nodes are sorted. The same process will repeat for all node, okay. This is a bubble sort technique, which has a worst case complexity of O of n square. Okay, each operation has a complexity in terms of big O notation. So check that also what is a big O notation. Okay, moving forward, what we'll do, we will repeat the process till all nodes reach their ordered position. Means the unless the linked list is sorted, we will repeat this process. There are many sorting algorithms, some take less time than other. Okay, bubble sort take O of n square, some algorithm will take that n log n time. Some algorithm are there which takes n log n time. So you can choose for a better algorithm and you can sort this particular linked list. Otherwise you can use the simple algorithm which is bubble sort for sorting the linked list by changing the data element, not by changing the reference. Why? Because if I want to change this 12, if I want to take this 12 to the right ordered position, what I have to do? First I have to do what? The 12 will refer, in this case we are considering from here, the 12 now will refer to this node, okay, and then this 8 must be referred by the previous one, okay, and now the 8 will refer to 12. So changing this lot of pointers is a complex. So that's why what we'll do, we will change the data value. It's not the case that it's not possible, it's possible, but it's a complex procedure. It will be a complex procedure, that's why we'll change the data value. So now see, when every node reaches the correct position, the list will be sorted, okay. So there's one more technique called bin sort. You can explore that also, which is applicable on linked list, okay. You can look for that bin sorting also. Now we'll look into the merge operation. So merge operation means merging two linked list. The merge is mostly performed on sorted data structure, okay. Merging two unsorted list is easy. You can add the second list at the end of first list or vice versa. But merging two sorted list, I didn't typo over here. Merging two sorted list and getting a new sorted list containing both element require comparison of each node first list to another node of the second list, okay. we have to compare each node of the first list to the node of second list, then adding the smaller node in the new list first. Okay, this is also a complex procedure, but we do not have to change much references. So what we are doing over here, in this merge operation, if we have this list, so what we are doing, we are adding the first list into the second, So consider this scenario for merge operation where you have two unsorted lists. What you can do, you can add the new list on the end of first list. Okay, so in this way what we can do, we have added this to list, both lists are unsorted, you can merge list 2 at the end of list 1, and what you have to do, you have to update the tail, only, then you will get your linked list. So it's a simple process. Let's see for the sorted list. For sorted list, you have to arrange nodes in their proper position. Nodes in their proper position. Okay. So what we'll do, we will compare list 1 first node with the first node of list 2. We will compare and add the smaller node in the new linked list and repeat the process until list is arranged. So what we are doing, we compare these two. This is the smaller, we added this into the new list. Now what we have to do? We have to move the head of this list. Now what we have to do? We have to compare these two and add the smaller one, 10 in the list. Okay, I kept it intentionally so I can show you the process. Now 10 is inserted and head is updated. Now what we are doing, we are comparing these two, and the smaller value is inserted into the list and head is updated to refer to this particular node. Now we'll compare these two, and so on. What we'll do, we will run the process unless one of the linked list will reach to the end, then the other list will be added at the end of the new list. So in this way what we'll do, we will merge two sorted list. So guys, that is all about the operations on linked list. We'll see you in the next video, which contains implementation for singly linked list, okay, doubly linked list and circular linked list. We'll consider insert, delete, search, traverse, sort and merge, all the operation in those videos. Thank you for watching.